All right, so today we're going to be covering section 5.5 only 5.5. And this section is on solving rational equations. And the first thing we might want to know is, how do I know if I'm looking at a rational equation? You know, looking at an equation, how do I know that it's rational? Do y'all know? Y'all know what it takes to be rational? Okay, I'll tell you. Two things. First of all, you have to have fractions. Secondly, you have to have a variable in the denominator. If those two things occur, you've got a rational equation. Got it? And I think it's important that you know how to tell what you're looking at. Because, you know, in my case, if my wife sends me to the store, to Walmart, to pick up a rational equation, and I come home with a quadratic, she's going to be unhappy. Right? So I got to know what I'm looking for. So we're going to start first example, number 3.
What page?
Let's do page 331. Page 331. And does this equation qualify as a rational equation? Does it have fractions? Does it have a variable in the bottom? So that's rational. And so the technique that I'm going to teach you for how to solve a rational equation is called kill off the fractions. We're going to kill off the fractions. But in order to do that, you have to get all the denominators to match. So I'm going to need to multiply 4 by something so that all the denominators can be the same. And this guy's got a 6, and he's got a 4. So what can I multiply 4 by so that I can make the two denominators match? Well, I could multiply him by 6, right? And then I can multiply him by 4. And 6 times 4 is, and 4 times 6 is, and then they match, right? I could do that. Or I could do 3. 4 times 3? And can I make 6 into 12? By 2. And that would be the LCD, the lowest common denominator. Now, did y'all notice that this denominator is also going to need an A? Because this guy has 1, so he needs 1. Now, whatever I do to the bottom, so if I give the bottom a 3 and an A, I'm going to have to give the top a 3 and an A. Now, what does the middle child need? He needs a 2. And what else does he need? An A. And so the top gets a 2A. Do y'all see what I mean by making the denominators match? So 4 times, this is now 12A. 2 times 6, this is now 12A. And now this guy needs to be 12A. So he needs a 12. So the top needs a 12. And do y'all see how that works? Building up the fractions so that all the denominators match. Yes? And once all the denominators match, then you can cancel them out. And that only works if you have an equation. It doesn't work with an expression. All right, so let's see what we have left over. 1 times 3A minus 5 times 2 and 12 times 1. And now do you see I have a new equation with no fractions? I can now solve for A. 3 minus 10? Yep, I'm going to combine my like terms and then divide both sides by. And I don't think that's going to divide nicely. So we're going to leave it F'd up. We're going to leave it fractioned up. And that's how that works. I mean, that's done. Do you have any questions?
Would it have worked had we used a larger number for the denominator?
Yes. The only difference is when you get to this final answer, it would have reduced. Like this one doesn't, but if you used a bigger number, this would reduce.
So we would have just had an extra step and we would have had to reduce.
Yes, but you would get the same answer. You sure would. Which is kind of nice to know that you don't have to get the LCD. Any common denominator will work. Now, are y'all ready for another one? Okay, here we go. Number 7. And does this qualify as a rational equation? Does it have a fraction? Does it have a letter in the bottom? Oh, it's rational, okay? And so what we're going to do, the same thing we just did, we're going to get all the denominators to match and then cancel them out. That's the overall topic, okay? Not topic. That's the overall, you know what I mean? That's the concept. Get the denominators to match and then you can cancel them out. Got it? Okay. Now the difference here is the x and the -9 are not fractions. But I can make them fractions by putting them over 1. Do you see you have to F them up? You got to fraction them up. And then you're going to make all the bottoms match. So what does the first denominator need that the other one has? He needs an x. Do you see the middle one has an x? So the first one needs an x. If I give it to the bottom, I got to give it to the top. Now look at the last denominator. What does he need? He needs an x. Giving it to the top. And does everybody agree that 1 times x is just x? X, x, x. Now they're all the same. Now you can cancel them out. Uh-oh, though. X times x? Oh, crap. I don't know if y'all realize what that is, but it's trouble. Plus 8 equals -9x. Now, does anybody know what kind of equation you have if there's an x squared? What do we call that kind of equation? If there's an x squared, it's a radical? No, that's with the square root. Is a radical equation. Now this one starts with a Q. It's a quadratic equation. Have y'all heard that before? Quadratic? Quadratic. Hey.
Oh, sorry. You see a blue backpack in here?
I haven't seen one, but you can look if you want to look around.
Oh, okay.
I haven't seen one. So, what was I just saying? I said anytime an x squared shows up, that makes it what? Quadratic. And if it's quadratic, I got to set it equal to 0. Have y'all heard that before? Man, this is good stuff. I hope you're getting it down. I will. If there's an x squared, that makes it quadratic. If it's quadratic, it has to be set equal to 0. So we're going to have to move the -9x to the other side so that we can set it equal to 0. And now we have something that we've not actually encountered this semester. We have a quadratic equation, and I'm going to force you to factor that trinomial. This is where you're going to have to go back to public school. I don't mean physically go back. I mean mentally go back and remember how to factor. Do y'all remember factoring trinomials? No, let's cover it then, okay? First of all, do y'all see this is a trinomial? 1, 2, 3. It's got 3 terms. It's also quadratic. And so that means that we're going to be able to factor into 2 sets of parentheses. So when you factor a trinomial, you're going to start with your 2 sets of parentheses, and then you're going to have to come up with the 2 signs. So is this going to be plus plus, plus minus, minus minus? I'm going to have to tell what those signs are. Okay, here's how we do that. You look at the last sign first. If this is a plus, these have to be the same. So now we know it's either plus plus or it's minus minus. How do I tell what it is? I look at the first sign. And so these are going to be both plus. I will repeat what I just said, okay? When you're factoring a trinomial, when you're going to read the signs, you have to look at the last sign first, okay? Plus means the same. Minus means different. Did y'all catch that? So if this last sign is plus, these have to be the same. If this last sign is minus, they're going to be different. So it'll be a plus and a minus. And when this last sign is a plus, you have to look at the first one to see what they both are. Got it? And just so you know, we're going to spend 2 or 3 days in the 0314 class factoring. So you're going to get a thorough review of factoring eventually in the 0314. Okay, so are we good with why they're both pluses? Okay, now what does it take to make x squared? So these first 2 blanks are going to be x and x, because x times x is x squared. The other 2 blanks are going to be numbers that multiply to make 8 and add to make 9. Can you think of 2 numbers that multiply to make 8 that also add to make 9? And I heard 8 and 1. 8 times 1 is 8. 8 plus 1 is 9. Do you see what those numbers have to do? They have to multiply to make this guy, and whatever this sign says to make this guy. Multiply to make 8, add to make 9. Got it? And now guess what we're going to do? Now that it's factored, we're going to set each factor equal to 0. And moving the plus 8 over, we get x is negative 8. That's one of our solutions. Moving the plus 1 over, we get x is negative 1. Hey, that's another solution. We actually got 2 answers this time. Man, I hope you're writing this down. This is good stuff.
I remember something like this. There's not, well, if the x was cubed, would there be an x on the outside?
Could be, but also if the x was cubed, you would get 3 answers. The exponent tells you how many answers you get. So how many answers will a quadratic always have? 2. What about if it's x to the 3? Then you get 3 answers. The exponent tells you the number of answers you get. Yeah, it's kind of cool. Now, is there any way to check and see if these are valid solutions? Let's check them. I want to show you how do you check your answers. So we always go back to the original problem. Okay, so there's what the equation looked like originally. And first we're going to replace every x with negative 8. So we're going to check negative 8 to see if it really is a valid solution. Does anybody know what 8 divided by 8 is? Anything divided by itself? 1. So that's going to be negative 8, but that's going to be negative 1. And does negative 8 plus negative 1 make negative 9? Oh, look at that. It checks. That checks out. Now let's check the negative 1. Negative 1 plus 8 divided by negative 1 equals negative 9. Does anybody know what 8 divided by 1 is? In fact, anything divided by 1 is itself. And does negative 1 plus a negative 8 make negative 9? Oh, snap. Look at that. Both answers checked out. Now do y'all see how to check your answers? I highly recommend that on the test. Plug your answers in just to make sure that they're right, okay? Okay, so we're off to a good start. Does anybody have any questions? Yes.
So you said when the symbol in the equation is a plus, inside the parentheses it's going to be both a plus, but if it's a minus, inside the parentheses it's going to be one minus and one addition?
That's close to what I said. Yes. So what I said is, if this guy is minus, these have to be one of each. And that's what you said, okay? Had that. But if this sign is plus, they're not always both plus. If this sign is a plus and this one is a minus, then these are both negative. Do you see if this last one is plus, these always have to be the same, and they're going to be the first one. And I think it's important to know how to read the signs. Yeah. All right, are y'all ready for another one? I got a few more to do. Number 13. Now, does this qualify as a rational equation? It's got fractions, and are there letters in the bottom? Yeah, in fact, this particular problem is a special kind of rational equation. This one has a special name. When there's only two fractions and one equal sign, do y'all know what that's called? It starts with a P. Not polynomial, no. It starts with a PR. Yeah, it's a problem. Well, it's actually PRO as well. It's a proportion. It's a proportion. Have y'all heard that word? You may remember from your high school that your teacher said, to solve a proportion, you cross multiply. Anybody remember that? To solve a proportion, cross multiply. So it's important that you recognize when you have a proportion. Because how do you solve a proportion? Cross multiply. All right, so we're going to have 2 times y plus 1, and we're going to have 3 times y minus 3. Now, do y'all see the real advantage to cross multiply is it gets rid of the fractions. No more fractions.
Now, why did you put the 2y plus 1 on the left and the 3 times y minus 3 on the right?
It just happened to be the way that I went first.
Okay.
So if you have these backwards, you'll get the same answer.
Okay.
So it doesn't matter if you go this way first or this way first.
So it doesn't matter which side we write either one on.
No,
Okay.
no. But I'll tell you something that does matter. If you don't put those parentheses, then you're going to be SOL. And y'all know what that means, right? Sure out of luck. Sure out of luck.
So we couldn't just skip that part and just multiply the 2 times both of the terms?
Oh, you can skip this step.
Yeah.
If you know that this 2 is going to distribute,
Yes.
you can jump straight to the next step. Yeah, and I'm all for you skipping steps if you can. So do y'all see the 2 and the 3 are going to distribute? Giving me 2y plus 2 and 3y minus 9. And yeah, you can skip straight to that step if you distribute on the fly. But now I'm going to have to get all my y's together on the same side. Who needs to move over? The 3y?
Or the two.
Two. Two y. It's the 9.
Okay, now the answer is either one. It doesn't matter, okay? Now there's some people that like to keep the letter on the left. They think it's got to say y equals at the end, okay? There's other people that think I need the y to be positive. And those people are going to move the 2 over. So what I'm going to do is I'm going to go with what I heard first. We're going to move the 3y, which means that the 2 also has to move. 2y minus 3y, negative 2 minus 9. 2 minus 3, negative 1, negative 11, and then divide both sides by y equals 11. And you'll get 11 either way. And if I wanted to, could I plug that back in and check it? I don't want to, but I could. How do y'all feel so far? You understanding it in the moment? When you get home, maybe different, okay? But right in the moment, we're good. Okay, let's see. Next problem, number 19. All right, how many fractions are there? 4? Okay, too damn many is the answer. There's too damn many fractions. I'm going to have to get every bottom to look identical. I need to go through and make every denominator look the same. So what can I do to the 2 to build it up to make it the same as the other ones? I heard 9 and x. And I like that, okay? Whatever I do to the bottom, I need a 9 and an x. So altogether, that first denominator is now 18x. So now I need to make the next one 18x. And he just needs a 2. And then the next one needs to be 18x. All right, so he needs a 2 and an x. Everybody with me? You see what I mean by making them all the same? And what does the last guy need? 3 times 6 is 18. 18x, 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 18x. Now they're all the same. Now you see them, now you don't. So what are we going to have left over? Awesome. Perfect. And now I have a new equation with no fractions to solve. Which x do you want to move over? Okay. So we'll take the 8x over, which means the negative 8 also has to move. And that's going to end up being 5. X equal 5. Right? 8. That becomes 9 minus 8, which is 1x. And that becomes positive 8 minus 3. 8 minus 3 is 5. Are we good? And then if I wanted to, could I plug it back in and check it? And again, I don't want to, okay? I'm lazy. You want to keep going? I got more to do. Okay, next. 21. Man, that looks exciting. Whew, man, that is effed up. That is fractioned up. And I'm going to have to get all the bottoms to match so that I can cancel them out. Yeah, so that's the question is, how can I make this denominator and this denominator look the same and do it legally? Okay, because if you're thinking, well, he just needs a -5, that's illegal. The only thing you can do to a denominator to make them look the same is multiply. So do you see this denominator is a binomial? This one is a monomial, right? One term, two terms. These are completely different. So this first denominator needs all of this denominator. The first denominator needs an x minus 5. He needs it all. Do you understand that? This is completely different than this, so he needs all of it. Okay? Now, what can I give this guy to look like this? Okay. Oh, and don't forget, this needs an x minus 5. This one now needs an x. And now what does the last one need? Man, I need to stress that again. Did you hear me say that when you're building up the fractions, the denominators have to be multiplied by other stuff? You can't add or subtract from them. And now do they all have the same stuff? Do they all have an x and an x minus 5? Now you see them? Now you don't. Let's distribute. 6x minus 30. Wait, did I miss something up here? Oh, crap. I copied the problem down wrong. That should have been 60. Dude. 60. I'm sorry. Yeah, that instead of 6 over x, that should have been 60 over x. And now 60 times x, that's going to give me 60x. 60 times 5, 300. I'm sorry, that's the first mistake I've made today. Equals. And then the 2 is going to distribute. 2 times 5 is 10. What do you notice?
The 60s are gonna cancel.
They are. You want to go ahead and do that?
Yeah.
Did anybody else notice the 60x's are going to cancel? 60x minus 60x, they're gone. And then who needs to move over next? Yeah, let's move the negative 10. Now that's going to make it a plus 10. So what is negative 300 plus 10? And then we're going to have to divide both sides by 2. Negative 1, I think it's 45? Negative 145. And then if I wanted to, could I plug that back in and check it? I don't want to. I'm lazy. Okay. I could. And do y'all have any questions about that problem? Anybody? Okay, next problem, number 21.
You just did that one.
Well, I'm doing a Britney Spears. You know what that means?
You're doing it again.
Oops, I did it again. I worked the same problem and got the same answer. Oh, baby, baby. Yeah. Doing a Britney Spears. Now, I'm going to work the exact same problem, but I'm going to work it differently. And I'm going to show you there's more than one way to get the right answer. Now, how many fractions are there? 3. Do any of those fractions already have a common denominator? So what I can do is I can actually put those two fractions together because they have a common denominator. If I bring this guy over, then I can put those two together. You understand what I'm saying? Okay, now just watch if you don't. So the 60 over x comes over, makes a minus 60 over x. And what do I have to add or subtract fractions? Common denominator. So these now both have an x, so I can do 2 minus 60 all over x. Do y'all see I can put those together? Hello, do you see that? They have a common, I can put them together. And now look what I've turned it into. The word I said a second ago.
Proportion.
Now it's a proportion, and that means I can cross multiply. And I don't know if you noticed, did y'all notice both of those fractions are negative? And I don't like that. So I'm just going to make them both plus. Is that legal? Whatever I do to one side? So if I change the sign on one side, change the sign on the other. That's legal. And then I'm going to cross multiply. 60 times x, 60x. 58 times x minus 5. And that's going to have to distribute. 58x. Going to need some calculator assistance. 58 times negative 5. Negative 290?
58.
Right? Negative 290?
Yes.
And then the 58x is going to come over and make minus 58x. 60x minus 58x. 2x. Divide both sides by 2. Oh, look at that. I got the same answer. Doing it a different way. How cool is that? I did it completely different. I got the same answer. Did you know that's true in math? No matter how you work the problem, as long as you don't break the laws of math, you're going to get the right answer. Okay, I thought that was cool that you could actually do them two different ways. Let's see, how are we doing on space? 20. Oh, we got space here. Number 21. Are y'all ready for the next one? 25. Next 25. Plus. Why did I put equals? 2. Plus. And this is where it gets fun. This is where we start having a lot more fun, okay? How many fractions are there? And did anybody notice that one of the denominators is a quadratic? Oh. In fact, this is a special thing. This is special. It's a binomial, right? 2 terms. It's a quadratic. It's got an x squared. But this is also the difference of 2 squares. Anybody remember factoring from high school? We're going to factor the difference of squares. This guy can be factored. Now, does anybody remember how to factor the difference of squares? Okay. Well, when you're first of all, the minus sign means difference, right? Difference in math is minus, and these are both perfect squares. So 2 squared is 4. X squared, it's x squared. It's squared. And so the signs for the difference of squares are always different. Difference of squares always have different signs. And then you just fill in the blanks. X times x, x squared, 2 times 2, 4. And that's factoring the difference of two squares. Now, I want you to notice that we needed to factor that so that we can figure out what everybody needs to look the same. Do y'all see that? See, this guy's got an x minus 2? Well, so does he. But what is this guy missing that this guy has?
X plus 2.
So the first denominator needs an x plus 2. And if I give it to the bottom, look at the last denominator. What does the last denominator need that the other two now have? X minus 2. And don't forget to give it to the top. And now do all the denominators have the same stuff? X plus 2, x minus 2. Now you see them? Now you don't. All right, so for the first numerator, I'm going to have to distribute this x. X times x. Uh-oh, that's quadratic. X times 2. 2x plus x. These two? Yeah, we can add those. Those are like terms. I'll do it in the next step. Oh, and look at this guy back here. That's a binomial times a binomial. That's the FOIL. We're going to have to FOIL that. OMG. Here we go. Let's F it up. X times x. On the outside. Negative 2 times x. On the inside. Plus 3x. And last but not least, minus 6. And I'm hoping at this point that y'all are getting pretty efficient at the FOIL method. That's kind of important. And now we need to combine like terms. Did anybody notice there's an x squared on both sides? Yeah, so what happens if I do minus x squared on both sides? And then I lose my quadratic. Now I don't have a quadratic anymore. And I said I would combine those on this step. So 2x plus x is 3x. Negative 2x plus 3x is x. Minus 6. And then if I bring this x over, that's going to give me 2x equal negative 6, or x equal negative 3. Questions?
Why were you able to subtract the x squared from both sides?
Whatever you do to one side, you have to do the other. And so the reason I did that is I noticed if I minus x squared from x squared, they cancel. But the same thing happens over here. Okay? So most public school teachers, I hate to keep saying that, but if you look at this step right here where I've got 3x equals x minus 6, yeah, a lot of times they'll show it like this, minus x minus x. You can do the same thing to both sides. Why would I choose minus x? Because it makes those cancel. So instead of moving it over, I can minus it from both sides. It's just another technique. 2x equal negative 6. I get the same thing. Yeah, so I can minus stuff from both sides if I want to. As long as I do the same thing to both sides. And does anybody have any questions about that? Let's see, when does this class end? 4:20. Blaze it. We're going to 4:20 blaze it. I got another one if you're interested. And I think I'm about out of, let's go to a new page. About out of room here. 27. All right, what I'm about to say is important, and I need to say this and make sure it gets on the recording. Are y'all ready? When you're solving a rational equation, any denominator that can factor needs to be factored. Any denominator that can be factored needs to be factored, okay? So looking at this first denominator, does that look like something that'll factor? Okay, we know that because it's a trinomial. It's a quadratic trinomial, and those usually factor. Now, do y'all remember how to read the signs? So if the last sign is plus, you have to look at the first one, and that's what they both are. So they're both going to be minus. Do I need to go over that again? I will. Again, you have to look at the last sign first. If this is a plus, you have to look over to the first one, and that's what they both are. Because a plus at the back says these have to be the same. Got it? Plus is the same. What if it's minus at the back? Then they'll be different, one of each. Next, x and x make x squared. And I'm going to need numbers that multiply to make 3 and add to make 4. You don't have a lot of choice there. What are the only numbers that multiply to make 3? 3, and you don't have any choice really, okay? Thank goodness they add to make 4. So we need 3 and 1. And does it matter what order I write them in? No, not when the signs are the same, okay? So that we took the first denominator, we F'd it up, okay? We factored it up. Look at the last denominator. That's a binomial. Do they have anything in common? So I can factor out a 4. Do y'all understand? If they have something in common, you can factor it out. What will that leave me with? X minus 1. And again, does everybody see if I distribute that 4 back in, I get back what I had. And so that verifies this is factored correctly. 4 times x, 4 times 1 gives me that back. Now, has every denominator that can be factored, has it been factored? And now we can go through and give the denominators what they need so that they all look the same. All right, so where should we start? In the middle. Okay, let's start in the middle. So this middle guy, he only has an x minus 3. What else does he need? He's going to need an x minus 1 and a 4. Because this guy over here has a 4 and an x minus 1. So the middle child needs a 4 and an x minus 1. And now do y'all see that the middle one, the middle fraction, has a 4, an x minus 1, and an x minus 3. It's got all 3 of those pieces. So now what does the first denominator need? He needs a 4. And now he has a 4, an x minus 1, and an x minus 3. And now what does the last one need?
X minus 3.
And so now he has 4 x minus 1, x minus 3. Do y'all see? This is now, I don't know, like the 30th time I've done, it's not 30th, but it's like the 5th time I've gone through and made all the denominators the same. They all have the same pieces, so I can cancel them out. 4 times 6, 24. And what's going to happen in the middle?
Minus 4. X minus
What is 1 times 4?
4.
And then is that 4 going to have to distribute? But did you see there's a minus out front there? And that means that minus also has to distribute. So it's really going to be negative 4x. And a negative make, that's going to be a plus 4. That's the most common mistake people will make on a test, is they will forget that negative out front has to distribute, and this 4 will end up being negative, and then it screws the whole thing up, okay? So I'm warning you. If there's a minus in front of a fraction, that minus has to distribute. And now would you like to combine like terms? Or would you like to move stuff back and forth? I don't care.
Combine on the fly.
Okay. We can combine on the fly. (24) and 4 is 28. 28 and 3 is 31. And that's 5x. If you want to do it all on the fly, doing it on the fly. So let's see if y'all follow me, okay? 24 plus 4. 28. And then this minus 3 is going to make plus 3. 28 plus 3. Negative 4 becomes, and 1 and 4 makes 5. There it is. And we're to the last step. Divide both sides by 5. Ooh, and that's improper. And that's the way I like it. If I wanted to, could I give a decimal for that? Is it a terminating decimal? And then if it's terminating, that would be acceptable. As a matter of fact, let's assume that we were working this problem to figure out how many miles I was going to drive, okay? Would you want to tell somebody, hey, I'm going to drive 31/5 miles? Or would you say I'm going to drive 6.2 miles? And see, there's a reason sometimes for you going to a decimal. Makes more sense. And I got to tell you, that's pretty much it unless you want to do one more problem. One more? Okay. And I've got a good one here. Let's do 34. Man, that's a massive rational equation. All right, so I think I just heard what I wanted to hear. What is the first thing we need to look for? If any of the denominators will factor. Will any of those denominators factor? Probably the middle one, because it's a trinomial. And I think we've done a few of those already today. So let's see if you know how to read the signs. And they are both going to be positive. And then we got y and y to make y squared. And again, you don't have much choice as far as the numbers go. The only numbers that multiply to make 3. 3 and 1. And do y'all understand that those work only because the middle number is 4? 3 plus 1 makes 4. If the middle number was 5, you couldn't say 3 and 1 because 3 plus 1 is not 5. Okay, and that means that it probably wouldn't factor. And then we'd have to do it a whole different way. Okay, but these are designed to work out. Now, what does the first denominator need that the middle one has? And if I give it to the bottom? And what does the last denominator need? So that they all have the same stuff. And now do all the denominators have exactly the same stuff? And then we can get rid of them. Bam. All right, let's distribute y times y. Y times 3 plus 3y plus 5. The middle fraction, the numerator didn't get anything, did he? The 3y, he didn't get anything, so he just comes down, 3y plus 5. And then the 2 is going to distribute 2y plus 2. And I'm feeling like let's move the stuff and CLT on the fly again. You know what I mean by that? Let's go ahead and move the 2y over and the plus 2 over. And we'll combine like terms on the fly.
Because you have to do it equal to 0.
Right. Why do I have to do it equal to 0?
It's quadratic.
Because it's quadratic. Yeah, you're learning. They can be taught. Here we go. Y squared. What is 3y plus 3y?
6y.
Oh, but look out. The 2's coming over and going to make a minus 2. Yeah, 4y. 6 minus 2 is 4y. And then what about 5 minus 2? And again, we had to set it equal to 0 because it's quadratic. And what makes it quadratic? The y squared. A squared means quadratic, okay? And I don't know if you noticed or not, but this quadratic, are y'all looking? This guy is exactly the same as that guy. So do you think this guy's going to factor the same? Let's F it up. Let's factor it up. Y plus 3, y plus 1. Going to factor exactly the same as it did before. And the difference now is, since it's equal to 0, I can now set each factor equal to 0. And moving the 3 over, y is negative 3. Moving the 1 over, y is negative 1. And how many answers did I get? I wonder if those are valid solutions. Oh, let's check and see if they're valid, okay? Now, do y'all remember this first fraction over here on the end? What was his denominator originally? Just y plus 3, right? So if I take negative 3 and plug it in for y, what is negative 3 plus 3? Well, can you have 0 in the denominator? Oh, So can this really be an answer?
No.
No. So that answer's no good. Did you see that? If it makes the denominator 0, it's not really an answer. What about this guy? What was this first fraction's denominator originally? Y plus 1? -1 plus 1.
So 0.
Uh-oh.
Is that no solution?
It is.
All that.
We got all that for no solution. We did all that work to find out there was no solution. Isn't that cool? I'm telling you, on these rational equations, you need to check your answers to make sure they don't make the bottom 0. Because if they make any denominator 0, they're not really an answer. There is not. No, if there was, I'd show you. Yeah, but the only way to know that it's going to be no solution is to work it and check it.
So we got lucky that 2 of the denominators happened to include the same number that we got as a solution, which made it 0, so we didn't have to plug it in the whole thing.
Yes, yeah.
But we're not always gonna get that lucky.
No. In fact, the main thing that you need to check for when you're checking an answer is, does it make the bottom 0? Okay? If it doesn't make the bottom 0, it's probably going to work out and you don't need to check the whole thing. But if it makes the bottom 0, you don't have to check the whole thing. It's an automatic failure. And y'all understand this is like real life. Right? Anybody ever used a dating service? Like you'll get 2 or 3 matches, and then you actually have to go on the date to see if there's going to be a solution or not, right? And you can go on all 3 dates, and it ends up being no solution. Yeah, this is real life. Okay, fine. Do y'all have any other questions for me today?